Yeah. Good morning, class. Today we are going to be talking about lung capacity. And do any of you have any ideas on how this household item, like a balloon, can be used in our respiratory system unit? All right, thank you for your responses. Today at our lab we're going to be using balloons to measure our lung capacity and relate it to the mechanisms of breathing, as well as just being able to calculate tidal volume and vital capacity. The lab handout is being passed around, and before we get started, I want to spend about 5, maybe 10 minutes talking about some general terms having to do with lung capacity. And you'll also get a chance to answer the pre-lab questions, which are an important part of learning. So what I want you to do is get into groups of 2. You're each going to need your own balloon. We don't want you sharing. And also, if you have a latex allergy or you're just not feeling well today, you probably shouldn't participate, but you can work with your partner and get your results that way. You're going to also need a meter stick and a metric ruler. To start, I want you to understand what tidal volume is. Tidal volume is the normal amount of air that we can inhale, which is our day-to-day normal breathing. So what I want you to do is take in, well, first you want to stretch your balloon lengthways like this. You need to get it loosened up, otherwise it's going to be kind of hard to blow into at first. So stretch it out, and then just take a normal breath and blow out into the balloon as much as you can, and then pinch it off. And I'll demonstrate that. Alright, so that's about as much as I can push out. So then what you're going to do is you're going to need your ruler right here, and you would lay it on a flat surface, I just can't right here. And then you want to place this away from where the ruler is and measure the balloon from its largest diameter, which is about the middle of the balloon. So place your ruler right up next to it, level, and then you're going to read the number that's top across here. And that is about 14.5 centimeters. And you want to record it in centimeters, and that record is going to go into data table number 1. Each student needs to do this. So you take turns. One's going to blow up their balloon 3 different times, and then the second student will blow up their balloon 3 different times. And once you're both done doing that part, the final data piece in your table is calculating the mean. So what you need to do is, for your tidal volume, is add up all 3 centimeter values you got and then divide by 3, and that gets you your mean for your tidal volume. Then we'll move on to Part B. Part B is somewhat the same as Part A. Instead of measuring tidal volume, we're going to measure vital capacity. Now, vital capacity is the amount of air your lungs can hold with a deep breath. So what you're going to do is take in a really big breath and then blow it into your balloon, and then once again pinch it off, and then you'll take your measurement. So I'll demonstrate vital capacity measurement. All right, so that time I did get more air, which makes sense. So then what I'm going to do is grab my ruler again. And like I said, I would place this on a flat surface. I just don't have one right now. So then place your ruler about level up to there, and then have your partner measure from the top biggest part of diameter part of the balloon and record your centimeters. So this time it looks like I got about 18 centimeters of air, in 18 centimeters cubed into the balloon. And then you'll record that in data table number 2. Repeat that 2 more times for the student who's doing it first, and then again the second student will repeat that 3 times. So you'll each have 3 values in data table number 2. And like with the Part A, you need to calculate the mean for your vital capacity as well. So once again, just take your 3 values, add them together, and then divide by 3, and that will give you your mean vital capacity. The final part of Part B on your lab is to calculate or to estimate your lung volume using the figure in the handout. On the graph on figure 2, you see that? Balloon diameter in centimeters is plotted against volume in cubic centimeters. You will use this graph to find the volumes that correspond to your diameter measurements for both tidal volume and vital capacity, and then record your data in Table 3. So for example, with my vital capacity, my measurement was 18, which is right there. So then you just follow that, and wherever that dark line crosses, you come across and find your lung volume, which is just showing about 3,000 centimeters cubed. All right, and that concludes Part B. Research has shown that vital capacity is proportional to a person's surface area. So Part C we will dedicate to finding our body surface area and relating that to our lung volume and vital capacity. The next 4 questions will require you to find your body's surface area using your height and your mass. Height can be measured using the meter stick that I've provided you. You'll just measure each other in centimeters and record that. And then for mass, I just want you to estimate how much you weigh in pounds, and I'll show you how to convert pounds to kilograms. So we'll need that number in kilograms to formulate our body surface area. Figure 3 will be used to estimate your surface area based on height in centimeters in weight. Once you have found your height and your mass, we'll then use Figure 3 to estimate your body surface area. If you look at this chart here, you can see height in centimeters, then your estimated surface area, and then your mass. So what you want to do is say that my height was 168 centimeters, and then my mass is 59, right around here. Then you'll draw a straight line between those two and come to a number that's located on the surface area. So about 1.6 would be my surface area if those were my values. And then we'll move on to the next part. Now that we've found our estimated surface area, we'll use that value to then calculate our estimated vital capacity using a formula. In the lab, the ratios are provided. The ratio is vital capacity to surface area, and for men and women that's generally different just based on that men are usually larger than women, and men have larger rib cages, so they have more room for expansion in their lung volume. So you'll want to multiply your surface area value by the ratio that's either male or female based on which gender you are. That value is then your estimated vital capacity. I'm going to be giving you about 35 minutes to complete Part A through Part C, and during that time I'll come around and check on you guys and answer any questions and help you out. Just see how you're doing, make sure you're grasping the concepts and what we're supposed to be accomplishing through this lab. Then we'll regroup and get together to finish Part D, and then after D you'll have time either in class or you'll have to finish it after class on your own time to complete the analysis and conclusion part of this lab. Great, now we've all completed Part A through C, and I want to move on to Part D. This is a really important part for learning scientific process and scientific inquiry. Most of you probably were standing when you blew into the balloons, whether you're doing the tidal volume or the vital capacity. What I want you to think about is how would body posture or anything that you are physically maybe doing at the time, how that would maybe affect your vital capacity, lung volumes. So I want you to create a question and then come up with a hypothesis about this lab and how it could be a little different. So for example, you could say the vital capacity when seated is going to be higher than if you were standing, and then what you're going to do is implement and describe your plan of action for this lab to answer this question, and then you're going to want to create a data table to put your values in. Within the part where you're describing your plan, I want you to consider any modifications you may have for Part A or Part B. Just think about how things could change physiologically, whether you're standing or sitting, and we'll get together and see what we've all come up with and discuss those. And then once we've done that, depending on how much time we have left, I'll let you work on the analysis and conclusion part, or you'll have to complete that after class on your own time, like I said before. The main things that I want you guys to get out of this lab is I want you to be able to form a hypothesis about vital capacity. You're going to design an experiment to test the hypothesis, and then also you want to relate the results to the mechanism of breathing. So we'll regroup and talk about how the tidal volume, vital capacity, lung volume, surface area, all those correlate to the respiratory system and how we breathe in our everyday life.